Okay, guys, let's get started with this. So first of all, does everyone have the handout? We all have it? Okay, we're good. Now, as you saw, the first 6 pages are just content review. So that's just for your benefit. You guys can read that on your own. I don't think I'm gonna go over those. Pretty self-explanatory. You just have to read those. So let's get started with the practice problems. Okay. Let's start with this one. Okay, so in this case, they're giving us the initial molecule and they're giving us the product. They're just asking for the reagents. So first of all, what kind of change do we see between the molecules? We're going from a secondary alcohol to a ketone. So what kind of reaction is gonna do that? It's gonna be an oxidation. So which option is gonna be the answer? It's just gonna be C. This is the only oxidizing agent. Now, technically oxidation shouldn't be on the exam, but just in case I included a few questions with it. Okay. Let's look at this guy. Multi-step synthesis. So, did anyone give it a try on your own? Nothing at all? Okay, take 2 minutes to try and solve it. Just 2 minutes. And for those of you who just joined us, please scan the QR code. Okay, we're all good apparently. Okay, what's going to be the answer for that problem? What do we think? We need a few more minutes to solve it. Or do you want to do it together? Okay, at least I get an answer with that one. Okay, so let's do this one together. So multi-step synthesis, that means you have multiple reagents. Now, very first reaction, we have to notice that we're starting with a benzene group that has a triple bond, an alkyne, right? Now, the reagent, it's a carbon chain with MgBr. What kind of reagent is that? It's Grignard's, exactly. This guy, it's Grignard's. Okay, now. Grignard's was very special. It could do 2 things, right? We can do a reduction, or what else can we do? Which one? Breaks the triple bond, yes, in which way? What kind of reaction am I gonna do? Do you remember? What other reaction does Grignard's do besides the reduction? Which is? If we're reacting with an alcohol, remember, this is gonna be an acid-base reaction as well. That was the tricky part with Grignard's. It's just acid-base. So we know that Grignard's is gonna be a nucleophile and a base at the same time. Now, in this case, we don't have any carbonyl groups. So we're not gonna be reducing anything. But we do have a terminal alkyne. That little hydrogen in here, this guy, it's very acidic. So this Grignard's MgBr goes away. You're left with the actual active Grignard's reagent, and that's gonna take away that hydrogen. So that means that we're gonna be forming a little conjugate base. Okay, so far questions on the first one. Do we all see it? We're good? Okay. Now, we have the conjugate base, and then we have an epoxide. What's gonna happen? Okay, so it's actually gonna be base cleavage. Don't get carried away with the H3O plus. We're going step by step. So first, we have that little negative charge from the conjugate base. This guy is gonna be my nucleophile also, nucleophile and base. So what was the ranking for base cleavage? For base cleavage, 1, 2, 3. In this case, is it gonna matter which carbon I cleave? No. So let's just say that I'm gonna cleave that one on the left. So my nucleophile attacks, that breaks the bond. And then we have this guy. Okay. I'm just connecting the epoxide. So first of all, questions on what just happened. We're good so far? Do we all see it? Again, if you have any questions, just raise your hand. It's okay. Now, with the acid, H3O plus, what am I gonna do? I'm just gonna protonate it. So this hydrogen is just gonna go over here. So we have an alcohol group at the end. So if we're creating that product, which of the following answer choices is my answer? Okay, I have one vote for 3. Does everyone agree? Yes, it is going to be 3. It's just drawn slightly different, but again, just count your carbons. Look at the connections. They're the exact same. So that's why C is going to be your answer in this case. Okay, question so far with that one. So far we're good? Yes. It got attached there. Wait. For the first one or the second one? The first one, we just took away the hydrogen. That's it. No, really quickly. Let's quickly scan the QR code if you didn't do so already. Let's quickly pull out our phones, scan it. Okay, looks like we're all good. Okay. Next one, multi-step synthesis again. Do you guys want to give it a try on your own or as a group? Group, okay. Okay, so we are starting with a little triple bond and we see NaNH2. What's that? It's just a base. We know that sodium goes away and we're left with the little negative charge. So what's gonna happen? What kind of reaction am I gonna do? Just acid-base reaction. So that base is gonna be taking away either of those hydrogens. So we're gonna have, let's see. Now, so far it looks very similar to the problem that we just did. We have the conjugate base, and then we are reacting with an alkyl halide. What's gonna happen? It's gonna be a substitution reaction. So that means that I'm gonna be attacking my carbon chain. This is going to be an SN2 like attack. I kick off my iodine. So then I just have this guy over here. Whoops, that's not correct. Okay, let's quickly erase the first few steps. I did a mistake while I was doing this problem. I did it from scratch, so that's probably why. So let's just scratch this part. The goal was to create, oops, that's not it. It was to create this guy, okay? The goal was to create an alkyl halide. So we're just gonna scratch off the first few reactions that we just did. Again, this was just a mistake on my part. So we're just gonna take it from that alkyl halide with a carbon chain that has magnesium. What do we think is gonna happen? Magnesium plus halogen. What's the only reaction that we've seen with magnesium? Grignards. We're going to be creating a little Grignards reagent. So we just wanted to create MgI in this case. It's not MgBr. So we know that goes away and we're left with the nucleophile. And then we have an epoxide again. So what's going to happen? Acid cleavage. We see a negative charge in this case. This guy is going to be your base cleavage. So same process. I just attack either of those carbons because it's equally substituted. And I just connect it over here. And then very last step, with H3O plus, what's gonna happen? We just protonate it. So we're just gonna add one of those hydrogens, and that's it. We're just supposed to end up with a carbon chain. Again, very similar problem than what we saw before. Okay. Okay, so far questions with epoxide and multi-step synthesis. So far we're good. Now keep in mind, Grignards technically shouldn't be on your exam, but on Friday he was including problems with Grignards and other reagents that you guys have covered in the first exam. So please keep that in mind. They might come back in multi-step synthesis. Like that reagent over there, PBr3. What was PBr3? It was a protecting group. So what's gonna happen to my molecule? Okay, so protecting groups, remember, we're just gonna be swapping our alcohol group for whatever halogen we have. So I'm gonna be preserving that carbon chain. And now instead of having an OH, I have bromine instead. Now, I have that alkyl halide. I see magnesium. So I'm gonna be creating my Grignards reagent. Now, at this point, we know that magnesium and bromine, they go away. We're left with the actual active Grignards reagent, and we have an epoxide. What's gonna happen? Exactly. It's the same thing that we saw before. Base cleavage. Is it gonna matter which carbon I attack? No. Okay, let's draw it again. Now, at this point, we know that we have our dear acid, so we're just going to be protonating that. So I have my alcohol group. Now, we have PCC, this guy. What was PCC? It's a weak oxidizing agent. What kind of alcohol group do I have? Primary, secondary, tertiary? It's going to be primary. I am only connected to one R group, exactly. So primary plus PCC, the weak oxidizing agent. What am I going to create? Which one? It's going to be an aldehyde, exactly. So I'm just going to swap that part. Let's see. Let's do this. Okay. We're just creating a little aldehyde. So far, questions on that one? We're good? Okay, question number 5. This is a conceptual question that we should know. So we're talking about the carbonyl group in this case. We know that the carbon in the carbonyl is going to have a partial positive because of that dipole moment. Because remember, we're looking at a structure like that. We know that we have a dipole moment going towards the oxygen. So I have delta positive at the carbon, delta negative at the oxygen. Now, what kind of attack are we going to do for the carbon in here? What's the name of the attack? It's just nucleophilic. Exactly. That's it. Okay. Question 6, it's all about IUPAC in this case. More specifically, it's about our ethers. So molecule 1, what's going to be the name? It's you have a benzene group, yeah, on both carbons. We really should know this one. We really should know this one. Okay, how do we name ethers? Let's just start with that. What do we do? Exactly. We're just gonna see what kind of carbon chains we have on the left and the right. It's gonna be benzyl, exactly. Benzyl methyl ether in this case. Now, in this case, remember, we're looking at that oxygen. We're just gonna see what kind of carbon chains are connected to it. On the left side, we only have one R group. How am I gonna name it? One carbon chain. It's just methyl. Okay, on the other side, I have a benzene group, but I also have a little carbon in between. What's gonna be the name? It's gonna be benzyl. Why wouldn't it be phenol? Exactly, we have a little bent in there. So this guy is just benzyl. So we're just gonna put them together. So this guy is gonna be benzyl methyl ether. Exactly. Now, the second molecule. This one should be easy as well. What's the name? Exactly. It's just a phenol group. That's it. That's the only difference. So this guy is methyl phenyl ether. And that's it. Questions on naming ethers. But what's the other way in which we could name ethers? With the ending oxy, exactly. Okay, are we ready to move on? Whenever you see a carbon chain that's branching off, that's going to be when you use oxy. Do we remember that? Let's go back to the handout. This was chapter over here. Okay, now, remember, we have two ways in which we can name the ethers. The first one was the easy one, when the ether is the parent chain. Now, the second one with oxy was whenever that ether was branched off from a carbon chain, okay? So, do we remember that part? A little bit. We don't remember at all. And actually, since we have more people, please scan the QR code really quickly. Okay, we're all good. Okay, one more. Okay, we're all good. Okay, now. For the next two, I'm gonna give you guys 5 minutes to solve it on your own. You guys can talk to each other. Just try to figure out what the answer is gonna be in that case. You guys can look back at your notes, that's okay. If you have any questions, just raise your hand. Which one? Remember, they're asking you for which statement is false. We talked about this during SI today. Read every prompt carefully. This was an actual exam question from a previous semester. Okay. Do we have an answer? Okay. Question 7. I have some votes for B. C. What about in the back? A. Okay. So in this case, first of all, they're asking us for the false statement. Okay, so let's go through each of those options. So A, it says that ethers are generally unreactive molecules towards reagents other than strong acids. Can someone simplify that sentence? What is it saying? Exactly. So that means ethers just react with acids. That's it, right? Is that true or is that false? That's true. That's what we were talking about on SI today. Exactly. The triangle, that's the only one that can react with bases and acids. So this guy is just true. What about option B? We're talking about boiling points. It says that ethers have a lower boiling point than alcohols, and it says that they have the same exact molecular weight. Is that true or is that false? What was the ranking for boiling point? Why? Hydrogen bonds, exactly. That was the reason. The stronger the intermolecular forces, the higher the boiling point. Ethers, what kind of forces do we see in there? London and dipole-dipole, exactly. Alcohols, what kind of forces do we see? Hydrogen bonding, that's the main one. So we know that. This guy is going to be true. Ethers are going to have a lower boiling point than alcohols for that reason. Okay, option C. It's talking about water solubility. It says that ethers have a higher water solubility than alcohols. How do we determine solubilities? Like diself-like, exactly. So we know that alcohols have hydrogen bondings. Water has hydrogen bondings. Ethers don't have hydrogen bondings. So this guy is false. So that's your answer. Option C. And then last one, D, is basically just rephrasing option A. And that's it. Okay, questions on that one? Okay, so far we're good. Again, please be careful on the exam. You have to read carefully each of the options. Okay, did anyone give it a try to question 8? With it or no? Okay, what's the answer for question 8? Okay, I have one vote for D. Does everyone agree? What do we think? 1 second, okay? Okay, let's take 1 second. Just take 1 to 2 minutes. Yes. But in this case, we're not given access. We're only given one equivalent of the acid. Okay. Did we get an answer? Okay. D, what about on the left side? Did you guys get an answer? Left side? D as well? So yes, you guys are absolutely correct. It is going to be D. Now, what kind of reaction are we doing there? It's not acid base. It's your acid catalyzed cleavage. Remember, we're just breaking open the ether. Now, we're just looking at, again, the carbons directly connected to the oxygen. The one on the left, what's the degree? Primary, secondary, tertiary? Left side. It's just secondary. What's that? In parentheses. Exactly, it's just benzene. Okay, so please remember that, yes. It's gonna look like this. Yeah. Whoops. Okay, the one on the right. What's the degree? The carbon. Primary. What was the ranking for acid cleavage? 312. Please remember that. Very important. The ranking, it is very relevant. Okay. So far, questions. Yes, Abigail. Thank you, Abigail. Yes, you're absolutely correct. I drew it wrong. This one I literally just copied and pasted it, so it shouldn't be wrong. So let's just add, there we go. Okay. Let's take a look at the next two problems. You guys have 5 minutes. Try to solve both problems. Mhm. If I'm cleaving the primary on the CH2. Secondary, this one is acid 3, 1, 2. Sorry, it should be C. Yeah. Quick correction for question 8. I marked the wrong answer. It's gonna be C. Do we all see it? Okay, good. That's it. Moving on. We have 43 questions, so. And again, take 5 minutes to solve the next two problems. And for those of you who just joined us, please scan the QR code. It should be at the very beginning of the page. Sorry, of the handout. It's posted. Oh, wait, give me 1 second. CO3H. CO3H? No. Peroxy acid. The bonds to the epoxide have to be cis. Yes. Okay, did we get an answer for question 9? Okay. E, does everyone agree? So, did we have to actually do the reaction for that one? No, why not? Exactly. As soon as you notice excess, remember, you just need bromines or you just need whatever halogen it was given. So we see excess, E. Simple as that. Okay, what about question 10? What's the answer for that one? I have 1 vote for 1. On the left side, what do we think? 1 as well? And you guys are absolutely correct. So remember, butene, this is just a double bond. And then all of this, what kind of reagent is that? It's an acid, more specifically, peroxy acid. Exactly. What was the main part that I told you to remember? CO3H, exactly. You guys don't have to worry about it. Actually, really quickly, how many Roche students do I have right now? Just raise your hand. Just 3? Okay, so 4. Don't worry about this first part, okay? You guys are not getting tested on this. So relax for now. Okay, question 11. 1 minute. 1 to 2 minutes. Pretty simple. Which one? 410. So this was one of the ways in which we can make an epoxide. Remember, we have 2 ways. First one, intermolecular West reaction. Second one, double bond plus peroxide acid. You know that it has to be a thin of it. That's why these 2 guys are. Okay. Okay, did we get an answer for question 11? I have 1 vote for 3. 3? Okay, so you guys are absolutely correct, but how do you guys solve it so fast? So yes, exactly. First of all, we see NaOH. This guy is just a base, right? Now, the molecule that we're given has halogen and an alcohol group. All of those components, what kind of reaction are they going to trigger? What's the name? It's going to be the intermolecular West reaction. Exactly. Those were the 3 main components. And we know that that one is always going to make a cyclic structure. In this case, it's an epoxide. So questions on this one? We're good so far? Okay, let's keep talking about epoxides. Again, please read that question carefully. They're given isotopes in this case. So take 2 minutes max to solve it, and then I need a volunteer. For 11, it should be 3. Okay, did we get an answer for this one? Yes, no? Anyone? Did anyone give it a try to this one? B and C, okay. You guys are wrong. Yep. You're still wrong. I'm not gonna tell you if it's A or the other one. Try to solve it. 1 more minute. Try to solve it on your own first. You have a 50-50 chance now. 50-50 chance.
Okay. You're cutting the bond off the here. You're cutting the left. Yes, left.
Do we have an answer? Is it A or D? C. So this one, if you said D, you're absolutely correct. D is a dog. Now, let's quickly take a look at option A. Option A is just a carbon chain with one alcohol group. Okay, now we are doing an epoxide cleavage. Usually whenever we do an epoxide cleavage, we end up with two alcohol groups, usually. So that was like your main key point, why A shouldn't be the answer. Now, no. Whenever you do a cleavage of an epoxide, usually we have two oxygen groups. In option A, we only have one, so it doesn't really make sense. So in this case, let's look at, whoops, that's not good. Let's look at our carbons directly connected to the oxygen. The left one, what's the degree? Right one? Ranking for acid cleavage. 3, 1, 2. Am I going to cleave the left one or the right one? The right one. So that means that the oxygen from the epoxide is going to be hanging from the secondary carbon, which is right here. And we know that eventually it's just going to get protonated. Now, on the side that we cleave, the primary carbon, technically we have a carbocation. So that's going to be where our reagent is going to be attacking. In this case, it's water with an isotope. So that's why we have oxygen 18 on the other side. Okay. Yes. HA is just indicating that you're doing an acid cleavage. HA, H+, those guys just indicate acid cleavage. That's it. Yes. I'm sorry? Yeah. Do you want it in bond line or condensed? Yeah. Then we end up with this guy. This guy is the same amount. Okay, there you go. Okay, questions with epoxides. So far, we're good? Okay. Let's look at the next one. This one should be your favorite question and very simple. What's going to be the answer? Which one? It is going to be A. What was the trick with that kind of problem? What do we have to do? Exactly. This guy is just the number of oxygens. Now, we know that the trick is that you can just multiply the number of oxygens by 3, and that should give you the big number in here, which is the number of carbons and oxygens. Again, this one should be a pretty easy one. Questions? Okay, we're good. Okay, now we're moving on to chapter 13 now. So now, Rocha students, now you guys can actually pay attention. This is going to be in your exam. Okay, this one. Again, this one should be pretty simple. So just take a quick look. What's going to be the answer? Beautiful. What about molecule 1? What kind of system do we see? Beautiful. 3, 4, and 5. What's the ranking for pi systems? Which one is the most stable? Second most stable? Beautiful. And last one? How do I know that I have accumulated system? Those ones are right next to each other. Exactly. So beautiful, guys. We're feeling more comfortable with chapter 13. How are we feeling with chapter 12? Yeah, you guys are not feeling too good with that one. We hate it. That's okay. It's okay. You guys are lucky you don't get it on the exam. Okay, now. It's practically been an hour, so we're gonna take a little break so you guys can keep eating. You guys can take a little bathroom break. I'm just gonna make a little pause every hour that we hit, okay? So we're gonna have 2 breaks in total. So again, you guys have like 6 minutes. We're gonna go back at 4, okay? Quick little break. We're back at 4. Go to the bathroom, get food. Yes.
Yeah, he did. You started? That's why you're looking at me like, like, do what you can based on what you know. No, I'm not. I know. I want to see like what I actually know. Yeah, yeah, he took that. Roll for no, me too. No, I'm there. No, you would think. Only awesome. Yeah. It's funny, it's like movie. I thought because I had it long ago. I went on the tape, but it was like. one, and you said it, like, we're at the point where you're learning all this stuff. It's
Wait.
I gotta. Oh, you didn't see him? I saw him. He walked in. Yeah. No, I feel you. You were here. Have you covered anything different than that we really? But getting a flat. So there's no telling them. So this is how I did. I took the and then question one.
Okay, everyone, it's 4. What? Please scan the QR code. If you didn't so already, please scan it. Okay, so far, how are we feeling after the first hour? We're good? We're good so far? Okay, let's go back to the handout. Okay. This one might look a little scary, so I'm gonna give you guys 5 minutes. Again, you guys can talk with each other. Group work is really encouraged. Again, 5 minutes, try to figure out the answer, and then I need a volunteer. Yes.
Or you could draw it out before it's not right. It's the one feeling for it. Okay. So like that 1, 2. So 1, 2 is actually scoring. Right? So that's not going to yeah. Stay there. Right? And this could be the other product. This person, the CL for that person here is not off the double. See what I'm saying? But in this sense, it is. No, it's not. It's not. Yeah, I'm thinking the right thing. Just because, so we consider it 2, 3, 4. So 8 is the first time you get that. Then you have like from the half. But if there's that double bond, right? But the field never get a certain contact with the double. So I can see. Yeah, that's what. Oh yeah, I agree. Yeah, I think that is. Yeah, you do the same thing. Yeah, you can't have a point. At least they would. You never see a purple crown off the solo. So if you compare one to all of them, at least if you compare one to I've never seen it. I saw it on the site.
13. Yep.
Never seen it. That's cute. Plus, I think there's residents there too. There, hold on. Yeah, that was great. Yeah. It's hold up. It's one apartment, but not one apartment. That has the high one. It's double one. Oh, it is. And that's the double. Because if there's a T and it's double one, then there's no H's coming off. If there's no H's coming off, it's going to be so this is the thing that's on right there. Right with that. Yeah. Okay, so yeah. So this time
Okay. Do we have an answer for question 15? E. And elephant is gonna be correct. Yes. No. Why was option E the answer? Why was option E the answer? Two products out of nowhere, yeah. So in this case, first of all, they're asking you for basically what's not the product. If we look at options A and B, what kind of product is that? It's the same thing. Is it 1-2 or 1-4? They're both 1-2. C and D. They're the same exact molecule. So what kind of product is that? It's just 1,4. Option E was the odd one out. So okay.
Yeah. So
Questions on this one? Okay, seems like everyone got it, so that's good. Okay. This one should be pretty simple. So just take a quick look at it. What's going to be the answer for that one? Give me a letter. Everyone agrees with E? It is going to be E. What's the name of that position in molecule 5? Benelic, beautiful. What's the ranking for stability? What's the most stable? Allylic then? Tertiary? Secondary? And benelic, beautiful. Okay, there we go. Benzylic, in this case, we don't have it. No. No, benzylic is always whenever we have a little benzene group. And it's basically like the allylic position. The only difference is that instead of having one double bond, it's the benzene group. So let's say that we're looking at this guy. That carbocation would be benzylic. And that's going to be even more stable than allylic. There we go. Okay. Questions on stability. We should be pretty good with this. Okay, we're good. Okay, same kind of question, but written slightly different. Do we need a little bit more than just 1 minute? Okay, we need more than 1 minute. Take 3 minutes max.
I want to say that's what I'm saying, but I feel like. So it's usually like it's not. I guess. Yeah. They got it on.
Oh my God, no. No, that one can wait. I don't like it.
But you don't like.
I hate it.
You know the answer.
Of course, I have the answer key. I need an answer key. Okay, for 17, what's the answer? Yes, it is going to be C. What kind of carbocation do we have? What's the degree? Tertiary. What about molecule A? What kind of carbocation? B. D. Primary, and last one is primary as well. Now, did we all get the answer for this one? Okay, again, the only tricky part was the condensed formula. That's it. 18. Okay. question, Alex? Yeah, you're correct. It is also lytic.
No, we did say that. Yeah, no.
Yeah. Yeah, you guys didn't mention it. Okay, question 18. What did we say the answer was going to be? Beautiful. B, E, yeah. This one is cumulative. These two. A. Mm-hmm. Yes. Okay. We're gonna look at question 19 and 20 at the same time. These are the only kind of questions that you might find. Roche, don't worry. Dr. Roche, you guys are chilling right now. Wes, you guys should worry about this one. I didn't expect you guys to show up. Okay.
Wait. What do you mean by West no West yet?
Yes. If you have Dr. Roche, do not worry about the next two questions. If you have Dr. West, most of you have to worry about these two. Okay, question 19 and 20. Okay, the answer for 19 is actually epsilon, C. For 20, it's B. Molar absorptivity. Okay, now, here's the thing. This is all about an equation that he briefly mentioned in lecture. It's the Beer-Lambert's law. Okay? Beer-Lambert's law. Do not ask me to draw out the equation. I didn't include it in the answer key. I did this last minute, so from the top of my head, I can't remember it. But those two questions are the only kind of questions that he asked on the exam. So it can be either or. So you practically can just memorize the answer for those two. So I'm basically giving you two possible questions that you might get on the exam. Yes. Oh, I have no idea. From the top of my head, I have no idea. I think it's A equals to epsilon something, but I don't know from the top of my head. You're not gonna ask for the full equation. So you guys can pretty much just memorize those two questions, okay? Those are the only kind of questions that you might encounter. So keep that in mind. Okay. I don't know. Okay, question 21. We have a little energy diagram. Okay, take a quick moment to read each statement carefully. Read each statement carefully again, please. Activation energy, oh, it's only with kinetic. Okay, Did we get an answer for question 21? A, B, none of the above? In the back, what do you guys think? What's the answer? Anyone from the back? You guys want me to call out your names? B? So those of you who said B, you guys are absolutely correct.
I was expecting you to say absolutely.
Absolutely wrong. No, not today.
Wait.
No. Option E. It just says that no conclusions can be drawn. Just please, like, forget about that answer choice. Like, it's never gonna be that one. So, yes. Uh. Okay. Okay, so little update. Wes and Roche students, you're both gonna worry about this question. Maybe Wes more than Roche. Yes. Yes. So in this case, for question 21, we didn't actually have to look at the actual diagram. Those statements can apply to general reaction. Sorry. There we go. Now. Yes. Okay. For any reactions that we do, the goal is always to create a really stable molecule, right? Okay, thank you. Yes. So we're gonna favor the creation of the most stable product. Therefore, it's gonna be created more rapidly in general. That applies for any reactions actually. So keep that in mind. That's why this guy, it's true. Now, the least stable product is gonna form rapidly. That doesn't make sense at all. It doesn't make sense at all. Yes. So kinetic, yeah. Kinetic is the one that happens rapidly, the one that doesn't do resonance. The thermodynamic product. Here's the thing. Kinetic is not always thermal. You guys, if you say that option A, if you yes. Now, let's look back at option A. Now, the most rapid product, it's kinetic. It's always kinetic. Okay? Now, we know that in some cases the product can be both kinetic and thermodynamic product. So that means that the molecule could be really stable. Therefore, A doesn't make sense. Plus, we can't really tell what kind of products we're creating. So A is not going to be at all in there. Yes. Then you can't tell anything about the actual intermediate. And okay. Okay, let's look at questions 22 and 23. They are conceptual questions. So let's take about 2 minutes or 3. Yes.
It's all kinetic because you don't have enough energy to make that big hybrid. So if you think a little. Okay, Oh, wait a minute.
Okay. Did we get an answer for question 22? What's the answer? Beautiful. Yes. You guys are absolutely correct. It says that it's at high temperature. Now, for question 23, what's the answer? Supersist, exactly. It has to be in the S-cis conformation. Okay, 24. Read the question carefully. Question 24. Yeah. Sorry, can you say that again? Yes, you're right. But whenever we're talking about temperatures, I would just focus on kinetic and thermal. 1, 2, and 4, they're not really telling you anything. Okay, answer for 24. Oh, okay, we have two different answers. This is why I'm telling you guys to please read the questions carefully. We're talking about the dienophile. And they're asking for the most rapid reaction. So what's the preference for dienophiles? Electron withdrawing groups, exactly. That's why A is the answer. Option C, that would be true for which reagent? Just for the diene, exactly. Okay, questions so far. We're good? Looks like we're kind of good. Okay, we're gonna... Okay, we're gonna start looking at question 25 and 26 at the same time. I'm gonna give you guys, let's say 3 minutes. Oh, yes. Yes. 13. We're still on 13. 13. Both questions are 13. Oh, yeah. Especially 26. It's a basic conceptual question. Sorry? It's a basic conceptual question. Okay, did we get an answer for 25? B or C? B as a boy, you guys are absolutely correct. The other answers that really do not make sense. A, functional groups, that doesn't have to do anything with the theory. Then the spin, again, it doesn't have to do really with the theory. It doesn't matter. And then for the other one, radicals. We never talked about radicals. 26. X or endo? It's so weird. Raise your hand if you think it's endo. Okay, mostly the left side. Lower down your hands. Who thinks it's exo? Raise your hand. Okay, it's pretty divided. So this one, it's exo. It is exo. No, we're not doing the groups right. No, that gets a little too competitive. Okay, so remember, to determine if it's end or exo, first of all, we're gonna look at our bridgehead. That's gonna be a reference point. This guy is pointing up. Then we're gonna be looking at whatever substituent we have. So in this case, the only one, it's R. This one's pointing up as well. Both pointing up, same direction, says exo. Yes. It's a boat conformation. This makes more sense for Roche students, okay? The both conformation makes sense for Roche students, okay? This is the hard part of having two different professors. Emily. This one, right? Okay, this one. In this case, our R group and the bridgehead, they're basically gonna be our one reference point. They're pointing up, okay? Now, on the bottom rings, we don't have any substituents. So that's why we're gonna be looking at the largest ring in this case, which is the one on the right. Because of the drawing, we see that the carbon at the bottom, this guy is pointing down. They are trans to each other, therefore they're endo. Okay? It depends where the R is placed. Abigail. Yes. Uh-huh. Yeah. If both are pointing up, it's cis, therefore it's exo. Okay, let's remember the relationships. Endo is my major product because it has less sterically hinder. It's less sterically hinder overall, right? Now, we know that's the case because our reference groups, they're trans to each other. Exo is the complete opposite. That's our minor product, okay? That one is gonna have a cis relationship. We have more steric hindrance overall. Questions on endo and exo? Exo is cis, yes. Sorry? Which double bond are you talking about? It shouldn't. Same rules apply. Okay, 27 and 28. They should be very simple. Okay, answer for 27. E or C? E. What do we think? 27, 27. So yeah, your elephant is gonna be correct again. Option E is the answer in this case. Okay, whenever they're asking for the shortest carbon-carbon bond, what are we looking for? Triple bonds. Yeah. Okay, so SP, these guys are the shorter ones. Okay, so that's triple bonds. Then it's SP2 or double bonds. And then the longest ones, SP3, single bonds. Okay, what about question 28? So everyone agree with B? A? No? B as a boy? Exactly. If they're asking for the longest wavelength, we're looking for the most conjugated one. Remember, that was the relationship. What was the relationship of conjugation and energy? Exactly, the lowered the energy. Okay, so far questions. Okay, so obviously we're feeling really comfortable with chapter 13, not so good with chapter 12. Okay, so oh yes, we're gonna do so. Okay, I expect you guys to answer the following questions really fast. 29, what's the answer? Beautiful. What could be another answer instead of pi 2 to pi 3? No?
Get excited all the time.
No. Okay, most favorable energy transition is pi 2 to pi 3. Two orbitals are right next to each other. HOMO to LUMO, that could be another answer. Okay. Exactly, but the answer is good to exactly say HOMO to LUMO. But not the other ones. The other ones do not make sense at all. Okay, 30. Sometimes, not necessarily. Okay, answer for 30. B or C? D? Raise your hand if you think it's B. Okay, lower down. What if you think it's C? Okay. What about option D? No one? Okay, thank you. Okay, so for 30, it's gonna be option C. Okay. Kinetic. Whenever we talk about that one, it's always all about the energy of activation. We don't care about potential energy. That can vary. Also, kinetic is not always the most stable product. B, it's true, but we want the most, the actual reason. Exactly. The actual conception. Exactly. Yes. Yeah. Left should be kinetic and thermal. Yeah. 31. I expect an answer really fast. B is a boy or D is a dog? Boy. You guys are absolutely correct. This one can go to the S's conformation because of that cyclic structure. It's locking it in that place. Okay. Questions. We get it? That one is going to be a diene, yes, but it's not going to be a good diene because the reaction just wouldn't happen. It could be a dienophyte, yeah, but it's not going to be the best one. It can be a dienophyte, yes, but it's not going to be the best one because it has electron donating groups. Huh. You're right on that one.
No, but the thing is, that this
Okay, you're right on that one, but you would have to really argue that with your professor to get this point. For this case, yes, you're right. He could be more specific. He should say diene or dienophile. But in this case, as soon as you see a conjugated system, just think it's only going to be your diene. Okay? Okay, this one. I also expect a fast answer. Church. Does everyone agree with Charlie? No one looked at it. Take 1 to 2 minutes. Okay, final answers. Did we say B? C. You guys are absolutely correct. Do we have questions on that one? Remember, this is your diene portion. And then your dienophile, it's only this. So we have this guy over here. There we go. Okay. Questions on that one? We're good? Okay, I'm glad that we're feeling better with this reaction. Yes. Usually, yes. Yes. This is a previous exam question as well. So. God, no, I expect the average to be higher than last time. Like, I really expect it to be a lot higher. 1 is the hardest exam, yeah. And then it gets easier. Easier and easier. In general, it's always like the first one is the lowest one overall, yeah. This one should be simple. Retrosynthesis, same reaction. What's the answer for 33? Final answer. It is gonna be C. Whoops. Wait. Yes. So in this case, they're giving you the product. You have to figure out the initial molecules. That's it. Okay. Okay, for the next 4 questions, I'm going to give you guys about 10 minutes or so to draw the energy diagrams. Okay? We're going to take our time. I want the answer, and then I want volunteers to show me both ground and excited state for each of the molecules. Two and three. Whoa. Thank you. Okay, there you go. Thank you for noticing that. God. It's not supposed to say that. It's supposed to say how. Okay, that's a typo on my end.
Don't want to look at the Okay. Then you keep right up.
Hmm? Sorry? 37 is. Hmm. Let's add option F. Thank you.
No, I was just reading through it. I was like, make sure I did it. So,
Let's add it to every single question.
yeah.
Can you like still see? Okay.
Actually, might be better.
Okay, that's awesome.
Here it goes. So, talk about. No, no, no. That's not. Yeah. Another one. No, hold up.
Also, really quickly, I added option F to every single question, which is option 0. Okay, so just keep that in mind.
All right.
What? Yeah. That's why you contribute the pi electron.
No, we're about to go over registry.
Wait, okay. Okay, can I get a volunteer to draw out the energy diagrams for question 34? Volunteer, come on. Anyone? Victims? Okay. No victims.
I thought we were gonna,
No.
well,
Sure, yeah, everything. The whole shenanigan. And also, what's the answer for that one?
yeah, no, you can go.
Not for this class.
No,
Not for this class.
just say how many electrons.
Just one.
Question, there's only two plastic orders in this compound, right? Three.
There's three. Remember.
Radical creates another one. Gotcha. I thought you were right. SP2 out of 3 or something. SP2 third.
They're SP2. So 34, it is correct. It is going to be B. NT.
So that's the first.
What?
It's just, you know.
Okay. Everyone, let's talk about this theory. Okay, so first of all, we're talking about the allyl radical. Now, we are correct. It is going to be 3 electrons, 3 pi electrons, okay? Now, the number of orbitals, that correlates with what? Number of sp2 carbons. We have 1, 2, and 3. Radicals are going to be considered sp2. Therefore, I'm just going to have 1, 2, 3 orbitals. I'm not going to have the 4th one in here. So then, if this is the ground state, we draw them from the bottom to the top. So we have 2 and 3. So yes, this guy is going to be HOMO. This guy is going to be LUMO. Now, the one at the very top, it is going to be NT. What about the middle one? Non-bonding. And then the bottom one? Bonding, beautiful. Number of electrons in bonding? 2. That's it. Simple as that. Questions on this one? Very good. Okay, who wants to draw the energy diagram for the allyl cation? Sam? Who wants to do it? No. That's easy. We're just gonna copy and paste it. Beautiful. Great job, then. Questions on 35. Yes. Exact. Lumo and non-bonding, yes, they're the same this time. So we know that the top one is anti, middle, non-bonding, bottom one, bonding. Now the difference between the radical and the cation is the number of pi electrons. For the radical, HOMO is going to be the non-bonding orbital because that's the one in highest energy that's occupied by at least one electron. And the cation is going to be the bonding orbital because that's the one in highest energy that's occupied. So that's why they're slightly different. Yes. Yes, absolutely. So let's draw the excited state for both cases, actually. This is HOMO. This is LUMO.
So that would be one pair.
Okay, so those are the energy diagrams for the excited state, yes. There's 3 levels because we have 3 sp2 carbons. Remember, the correlation of orbitals was to the number of carbons that are sp2. Carbocations, carbon ions, and radicals, they're all going to be considered sp2. Okay, so far, questions on 35. We're good? Okay, it's been the second hour, so we get another little break. So, second hour is going by fast. So, go for water. Keep it in your lunch if you want. Or go to the bathroom. Or just stand up and stretch a little bit. Get blood flowing. Okay, everyone. So let's wrap up our conversations. Let's continue with the review for 1 more hour. 1 more hour. And then you guys are free. Okay. So for question 36 and 37, we're looking at the same exact molecule, 1,3-pentadiene. Who can draw it out on the energy diagram? Okay. And beautiful drawing. That's the correct one. What's going to be the answer for 36? Okay. So far, you're... For 36, did we all get B? Yes? Did anyone get 4? Yes. Okay. So again, I'm gonna say it again, but please read each question carefully. In this case, they're asking for the orbitals, not electrons. So we only have 2 bonding orbitals, so that's why the answer is gonna be 2. If we were asked for the electrons, then it would be 4. Okay. Okay, for 37, this one should be pretty simple. We don't even have to draw it out. It's always going to be 0 because if we talk about LUMO in the ground state, it's always going to be empty. Questions on those two? We're good? Okay, we're good. So now let's jump into chapter 14. Sorry, that wasn't me. That's on me for not checking the answer choices. So yeah. Next time I'm not gonna give you guys answer choices, just so you can figure it out on your own. Okay, 38 and 39 should be pretty simple. For 38, which one is aromatic? Beautiful. Huckel's rule. How many pi electrons do we see in total? 6. Molecule 1. What kind of system do I have? Whoa, whoa, whoa. Molecule 1. What kind of system do we have? Not aromatic. This guy's aromatic. What about molecule 3? How many electrons do we see? And last one, 4. How many electrons? Beautiful. Okay. So in the aromatic, it follows. Yeah, I'm gonna pull out the table actually. Yeah. That's a great idea actually. That was good. So that's your table. Non-aromatic, it breaks any of the 4 rules from aromatic. And then anti-aromatic, it pretty much has the same exact rules as anti-aromatic has pretty much the same exact rules as aromatic. The only difference is that bottom part, the one that's highlighted. Yeah, so there's tutoring tomorrow from 9:30 until 1:30. You guys are more than welcome to join me. 9:30 until 1:30. The SLC. Do we all know where the SLC is? Nope. Who doesn't know where the SLC is? Just raise your hand. Okay. Where is the SLC? Right next to the stadium, yes. Just walk out of the breezeway, past the gym, keep walking straight to the garage. Slightly to the right, that's the building. That's it. Yes. Appointments are highly encouraged, but if you don't make appointment, it's okay to drop in. I can take as many students as I can possibly hold. Okay, 39. What's the answer? Which one is aromatic? How many pi electrons do we see? What kind of system do we see in molecule 2? Molecule 3? The rest? Beautiful. Okay, let's look at questions 40 through 42. Okay. This one has a lot of words. Okay, so yes, we're talking about hybridization for the nitrogen specifically and this molecule. Does everyone agree? Is it going to be sp2? Yes. Double bonded heteroatoms, they're always sp2. Now, it says that if we assume that sulfur chooses to be sp2, how many pi electrons do we see in total? 6. In this case, exactly. So we have 1, 2, 3, 4, but it says that the sulfur is going to choose to be sp2. So because of that single bonded heteroatoms, the rule is that it donates 2 electrons. So we see 5 and 6 in that case. Single bonded. That one is, it can choose to be planar or non-planar. Yeah, of course. Okay. Okay, let's just look at the molecule. Okay? Let's take it by step. Now, first of all, is the molecule cyclic?
Yes.
Is it planar? When can it choose to be non-planar? If it has 8 or more members. Beautiful. Is it fully conjugated? It depends. So, first of all, we see nitrogen, that one's double bonded. Double bonded heteroatoms, they're always sp2. But we see sulfur. This guy, it's single bonded. So that's when it can choose to be sp3 or sp2. If it's sp3, what kind of system? Non-aromatic, because it breaks the rule of fully conjugated. If it's sp2, what's the rule of single bonded? How many pi electrons does it give me? So yes, remember, single bonded heteroatoms, if they choose to be sp2, they're going to give you 2, okay? Yes. Yes.
Oh, it makes non-aromatic. And would it sp2, would it make a double bond?
No. It's just how the orbitals are drawn, basically.
So you're not making another double bond?
No. Okay, so in total we see 2, 3, 4, 5, 6. Which is aromatic. Okay, now, last question, 42. What for this molecule at least? What kind of reactivity do we see in that molecule? What does that mean? We don't know at all. Any guesses? Educated guesses. Which one do we see? Reactivity. How do we answer that question? I mean, you are correct. It would be a dienophile, yeah. Okay, so right now we're in chapter 14. Okay? We're in chapter 14. Aromatic, non-aromatic, anti-aromatic. Those guys are telling you the reactivity of the molecule. Beautiful. It is going to be aromatic. That's it. This is coming from his actual practice problems. But again, remember, you're going to have multiple answer choices. So you guys are going to be able to figure it out. So don't worry. It's multiple choice. Don't panic. It's multiple choice. Yes. Okay, let's look at question 43. Conceptual question. Again, please read carefully. Read together, yes. Yes. Okay. Answer for 43. You guys are correct. It is gonna be Bravo. Yes. Yes. That's completely okay. So, Huckel's rule. Huckel's rule, remember, is one of the rules for aromatic compounds, okay? So basically, it's just asking you which of the following statements is not one of the rules for aromatic systems, okay? So let's look at each one of them. A, we know that. It has to be planar, so this guy, it's true. Then Huckel's rule, we know that the little equation is 4n plus 2. So this guy is good. Now, option D. Can someone paraphrase that? Exactly. It just has to be fully conjugated, which is true as well. And then option E just says that none of the above. So this guy, monocyclic. We know that one of the requirements for aromatic, it is cyclic. Now, that can be 2 rings. That can be 3 rings, okay? Exactly. It's not always going to be only one singular ring. Mono just means one. Okay, questions so far. We did 43 questions. We good? Okay. They have 15. Okay, don't get scared. Dr. Roche, it's 13, 14, 15. Dr. West, 12, 13, 14. Okay, do not mix them up. Okay, so far. Guys, really quickly. Everyone, Okay, we're still talking. Okay, so you guys are gonna be raising your hand if you feel really comfortable with the chapter that I'm gonna say. Chapter 12. Oh wow, that's so bad. Yeah. Raise your hand if you feel comfortable with chapter 13. Okay, that's good. Chapter 14. Not that many? I was expecting everyone to raise their hand. But okay, I mean, we're 13, pretty good. Okay, so we're gonna be reviewing chapter 12 for a little bit more. Do you guys want to keep doing the review? Okay, let's go back to 12. Guess it's a little concern. Oh, do you want to do the same questions? Sure, yeah. Yes. Yeah. Christian is gonna do a review for you guys. Christian is doing a review for you guys. No, he's doing it for Tuesday and Thursday as well. So, okay, so really quickly for Dr. Roche, Christian is gonna be making a review for you guys that it's gonna include chapter 15. So do not worry, you guys are gonna have extra practice problems. From me, no. No. Christian is the SI leader for Dr. Roche. So he's in charge of you guys for Dr. Roche. Okay, okay, 12. Actually, no. Let's go back to the actual review. With someone else. Okay, so first of all, did everyone scan the QR code at the very beginning? Okay, awesome. That can be everything. But okay. So I'm gonna start going through that little conceptual summary that I did for you guys. So you guys can refresh on the actual reagents that you should memorize. First one that most of you forgot is protecting groups. So let's simplify this one. You guys are just gonna be working for group 1. Okay? That's the easy one. We see some sort of halogen in there. Remember, the trick was that you're just replacing your alcohol group for whatever halogen you were given. So let's say that you're given this molecule plus PCl5. What's gonna happen? Exactly. CH3Cl. That's it. That's your main reagent. That's gonna be your main product, sorry. Okay, protecting groups are that easy. You're just swapping the alcohol group for whatever halogen. Usually, you guys are not provided with substrate, actually. They're not provided with a substrate, so I don't know. Okay, oxidation. This one might or might not be on your exam. It wasn't tested on the first exam, so it would be fair game for it to show up on the second one. Okay? Now, this one, we have a few reagents that you should memorize. Now, you can just memorize the weak ones. Those are the easy ones to memorize, just PCC and DMSO. That's it. Anything else is going to be a strong oxidizing agent. Also, notice that we have a bunch of oxygens in those guys. So as soon as you see a bunch of oxygens, that should point you to a strong oxidizing agent. Now, the only things that you have to remember are the transformations. If we start with a primary alcohol, depending on what kind of reagent we use, we're going to get different products. If it's weak, we always create our aldehyde. If it's strong, it always creates the carboxylic acid. We saw those reagents actually in one of the multi-step synthesis problems that we did. Do we remember them? No one? It's fair game. Technically, even Grainer's is fair game. Okay, let's do a little practice problem in here. Okay. Do you want to show it? Secondary. We're only looking for connections to carbons. So far, we're good. Beautiful. That's for the first one, yeah. Do everything. Game of four. What's that? Let's assume that it's just game of four. You only have to worry about one temperature. Room temperature. Okay, let's say room temperature. We just saw it. We just saw it. Does anyone remember? It's a strong oxidizing agent. Juan, show me the products. In this case, yeah, we're going to assume that it's in excess. So that means that the oxidizing agent is going to attack every single alcohol group. Look at the degrees of the alcohol groups. That's very important. So that means you're getting two different products. Two different transformations. Secondary alcohols, they go to what? To what kind of carbonyl? Yeah, probably not. Okay. Okay, oxidizing agents. Remember, we're always creating some sort of carbonyl group. Now, in this case, we have a secondary alcohol. Secondary alcohols, they're always going to get transformed into what? It's always going to be transformed into a ketone, exactly. So, there we go. That's your ketone. That's it. Now, on the other side, we have our primary alcohol plus a strong oxidizing agent. What's going to happen? Carboxylic acid, because it's a strong oxidizing agent. If we KMNO4, that's a strong oxidizing agent. So in this case, we're just going to have CO2H. Oops. Yes. we would still have that ketone, and instead of having a carboxylic acid, it would be an aldehyde. Okay, we're starting to remember a little bit, hopefully. Hopefully. No, if it's a strong oxidizing agent, it's to a carboxylic acid. If it's weak, aldehyde.
And it also depends
On the degree, exactly. Okay. This is just showing the transformation from primary alcohol to carboxylic acid. Carboxylic acids can be drawn this way. We never talked about tertiary alcohol groups being oxidized. We don't talk about it. We don't talk about it. Yeah, we don't talk about it. So far, questions about oxidation. So far, we're good? Okay, we're good. Now, this was the killer for most of you. Your dear ethers and epoxides. Okay? So, let's talk about how to make our little ethers and epoxides. So, we know that the West reaction is usually the one who's going to give you your ethers or epoxides. Okay? What were the main reagents for that reaction? The West reaction.
Oh no, it's
No. We're just talking about the West reaction. We talked about it at the very beginning. Abigail. Strong base. That's one of the factors. Beautiful. So we need some sort of base like NaOH. We need some sort of halogen. Can be chlorine, fluorine, any of those guys. And then we also need some sort of alcohol group. The alcohol group that's acting like a base. Sorry, like an acid. Correction, like an acid. Now, please remember that we're only going to be calling epoxides to little rings that look like a triangle. So that means one oxygen with 2 carbons. That's it. If we have more than 2 carbons, then we're just going to call it a cyclic ether. Okay, do not confuse them. Again, triangle, epoxide. That's it. Now, for epoxides specifically, we had another way to make them, which was the one with peroxy acids. What was the main portion that tells you that you have a peroxy acid? CO3H, beautiful. So you have just 2 peroxy acids, and what they have in common is just CO3H. That's it. Now, the next thing that you should know is that it's a syn addition. So that means that the bonds that are making the epoxide, so bond between carbon and oxygen, they should be on the same plane. Okay, and that's it. Question? Yes. But in this case, I just decided to write it as condensed formula because most likely you're going to get it that way. This whole thing, it's MCPBA. We had 2 ways to name that molecule. That whole thing in condensed formula or just MCPBA. Most likely you're going to get the condensed formula one. Okay? Okay. Okay, guys. So we know how to make our little ethers and epoxides, right? We have to learn how to break them. Now, normal ethers, okay? Not epoxides. Normal ethers, either linear or cyclic. They are only going to be cleaved with acids. Only with acids. Please remember that. The epoxides, those guys can be cleaved in both acids and bases. That was the main difference. Triangle, yes. Triangle reacts with acids and bases. Something more than just a triangle, just acids. What do you mean? If it's a square, then it just reacts with acids. That's still an epoxide. We still have the triangle. Okay. First of all, questions on how to identify the epoxides versus cyclic ethers. Do we know how to identify them? Are we comfortable with that? Okay, really quickly. Let's look at the next few molecules. Okay, molecule A. Is that an epoxide or a normal ether? Exactly. As long as you see the triangle portion, this guy is your epoxide. Molecule B. Not epoxide. This guy is just a cyclic ether. Beautiful. We see a triangle, epoxide. D, not an epoxide, not a triangle. This guy. Exactly. You can have substituents to the triangle, okay? Okay, now, we were talking about breaking our epoxides. We have to remember the ranking. For base cleavage, it's going to be primary, secondary, tertiary. 1, 2, 3. For acid cleavage, if you're taking Dr. West, 3, 1, 2. If you're taking Dr. Roche, 3, 2, 1. So for, so for questions, we're good? We know how to break our little epoxides? Okay, crown eaters, this should be your favorite question. Okay, we should love it. You might only get one question, but still. Again, remember, the big number is going to be the first one that you're going to see. That's including the amount of carbons and oxygens. The small number, the one that goes before ether, that guy is just accounting for oxygens. So please do not confuse them. Okay, so let's do a few practice problems with epoxides. We said it so many times. I really hope you guys remember this one. Okay. Reaction A should be pretty simple. What's the answer? Beautiful. This one, just no reaction. Okay, who wants to solve reaction B and C? Volunteers. Anyone? Okay, give it a try, yeah. And OH always on both sides? As long as you know where to cut it, yeah, you can skip the mechanism. Yeah, that's just my handwriting. Instead of the A, it's gonna be a specific group. HA is just indicating that you're doing an acid cleavage. Okay, what do we think? What do we think? Left side. Do you guys agree? That's the difference. Exactly. So first of all, HA just means that you're doing an acid catalyzed reaction. Okay, we got that. Whatever's on top of the arrow, that alcohol group, that's going to be connected there. We're not going to be adding an alcohol group in that case. So instead of that alcohol group that you just drew, it would be an oxygen with a methyl group. Okay. So do not always assume that you're going to end up with two alcohol groups. You're always going to end up with one alcohol and one whatever's on the arrow. There you go. Beautiful. Great job, Nick. Do you want to give it a try to see? Beautiful. You got it. Great job. Okay. So far, questions with epoxides. Yes. What triangle? That's just my handwriting being really crappy. That's supposed to say HA, not H triangle. Yeah, that's on me. Sorry about that. No, yeah. It's the handwriting. I'm sorry. See, it's there you go. Okay, now. Raise of hands. Yes. You guys can take a picture, more than welcome to do so. Raise your hand if you feel really comfortable with chapter 12. This is chapter 12. Okay, I have one extra hand. That's improvement. Yeah. Yes.
Are the, well, I think I asked you already, but I forgot. Are we doing the entire William feature? We have to know the entire mechanism.
You don't have to know the entire mechanism.
Oh,
Actually, no, yeah. I'll just leave it like you have to know the mechanism. Yeah. It's easier to follow. It's easier to follow. But again, you're never gonna have any questions about the actual curve there, mechanism, what goes to what side, all of that. As long as you know the initial molecule, final product, you should be good. Okay. Yes.
like you have double bond, right? And then it turns into the pot. That's the mechanism.
Yeah.
That's it.
No. Double bond plus peroxy acid, that gives you your epoxide. Yes.
And
There you go. I can draw the first one, not the second one. That's the peroxy acid drawn out. The other one, I can't draw it from the top of my head. Like, no. Exactly. We have Google for that reason. Okay, are we ready for one more multi-step synthesis? Yes. Only the right side is excited and awake. Left side, you guys are okay? Okay, let's go to the bottom of the handout. Yeah. 44. Okay. There you go, guys. Take 5 minutes max to solve it. Yes. Yes. You guys can talk with each other. You can look back at your notes. That's okay. Oh, good. I forgot that you guys wanted the West reaction. Okay, next one is gonna be the West reaction. Sorry. Okay, now we have two practice problems. Actually, let's add something more. I just added it. Sorry, I'm adding one extra reaction in there just because. ionic bond is not fully stable. It's just salt. So they're separated. Covalent bonds, they're fully connected.
Is that like so covalent is like carbon.
Yes. Okay. This time it's okay, yeah.
Oh, which one's the good leader? So then the that it's not big. It's minus
Okay, can I get one volunteer to start solving the first one? 44. First one, too rough. No volunteers? No? Okay, let's do 44 together. Okay, let's do it together. Okay. Okay, so we have an alcohol group in this case, and we have SOCl2. What's SOCl2? It's a protecting group, exactly. Swap out the OH for the Cl, yes. Yes, exactly. But in this case, everything's planar, so it doesn't matter. No, I have an alkyl halide that's reacting with magnesium and ether. What's gonna happen? What am I gonna create? Whoa, that's not VR. Sorry. I got a little too excited. Sorry.
So my question is, would you use phosphate and add it where the
MgCl is just your byproduct. We don't care about that one. This guy, we don't care. We just cross it out and we're left with the nucleophile slash base. Okay, okay. Hold on. Hold on your questions until the end. Just, okay. Okay, so we have a base plus an epoxide. So what's going to happen? Left one, what kind of degree do we have? Tertiary. Right one is primary. So, of course, we're going to be attacking here, and we're breaking that open. So I have this guy. I have my new connection to the primary one. This guy's primary. This guy's tertiary. And then we have our little acid. So acid-base reaction. Questions on this one? Did anyone get that answer? Okay, we got that answer. Thank you. What? Did I? Wait, no, yeah, it's correct. There's no extra carbons this time. Okay, let's say that this guy is going to be carbon 1, carbon 1. Then, since I'm connected to the primary one, this guy is going to be my carbon 2. Then I have 3, 4, and then let's say that the oxygen is just 5. So I have 2, 3, 4, 5. So in this case, there's no extra carbons. from the epoxide.
You just kind of flip.
Yeah, sorry. Okay, questions on 44. We're good? Makes sense? Who wants to give it a try to 45? No one? Not at all? We want to do it together again? Okay, so let's do this one together.
Oh, it adds 50 bar.
Exactly. Okay, so in the first one, this is our reaction from Orgo 1, chapter 8. This is your halohydrin formation. So we are gonna get rid of that double bond. Good old day. We have, let's say, alcohol group, bromine over here. What you have to know is that you're always adding some sort of halogen in an alcohol group, and they have to be trans to each other because this is an anti-addition.
What?
Yes.
So the first step is you're adding bromine trans to each other, correct?
Bromine and alcohol, they have to be trans to each other. Exactly. Yeah, that's your intermediate.
Yeah. So the intermediate would be bromine.
Technically, intermediate is going to be a little triangle. There's not going to be an oxygen in there. Do you guys want to see intermediate? Okay, let's show them the mechanism. Let's just go back to this one. Okay, there we go. That's a triangle intermediate. Okay. Does that clarify some questions? It does? Okay. We guess. We're taking a picture. As long as you remember that it's an anti-addition, you should be good. Okay? You're not going to get asked about the intermediate. Let's go back to the handout. Yes, for any halogens. Any halogens.
Didn't he say there was like an expected?
Yeah, usually we don't care about iodine or fluorine. We just love chlorine and bromine. Okay, so we have our dear halohydrin and we have NaH. What's NaH? Exactly, it's just a base. What's gonna happen? What kind of reaction am I gonna do? Substitution, because at this point, you're doing your West reaction. Okay, this is when you start doing your West reaction. So that base is gonna deprotonate our alcohol group. So we have an O minus at this point, which now means that I have a good nucleophile that does the backside attack and that kicks out your bromine. Let's move it a little bit to the left. So I have that oxygen, and now I have that new connection. I just made my epoxide with the West reaction. So far, questions? So far, we're good? Yes. Okay, now we have our epoxide and the next reagent. What kind of reaction is it going to trigger? So yeah, this portion was SN2. That's why we flipped the stereochemistry. Now, we have an epoxide and we have everything in that area. I'm not going to say it. Okay, potassium. That guy is an ionic bond, right? Come on. Okay, thank you. So we know that it just goes away and we're left with this. What kind of reagent is that? It's a base. Exactly. Base plus epoxide. What's going to happen? What's the ranking? 1, 2, 3. Okay. Let's look at each carbon. The top one. What kind of degree is it? Beautiful. Bottom one. Secondary. Which one am I going to cleave? Top or bottom? Bottom. So I'm just going to cleave that one. So that means that the oxygen from the epoxide is just going to be hanging off from that tertiary carbon. So I have that methyl group. I have that oxygen. Right now it's oxygen minus. And now, let's see. This portion, your nucleophile slash base, that's what's going to get connected to the secondary one. Okay. So in here, we're just going to have oxygen with 1 and 2 carbons. And we know that at the very end, we're just going to protonate our product. So we have an alcohol group. So we know that the shortcut for cleaving epoxides is you're always going to end up with a molecule that has 1 alcohol group and whatever was on the arrow. That's it. Okay. Yes. On the arrow. From the solvent. Yes. Yes.
So that, the ethanol would be okay. If you would have put those reagents, would it be by acid?
No. It would still be base. You only know that you have an acid cleavage whenever you see HA or H plus. Okay, so that's it for this review. No problem. We've done 3 hours of our review, so hopefully that answers some of your questions. Remember, there's tutoring tomorrow, 9:30 until 1:30. Please make appointments. For the handout? I can send it to you.
I'm trying to scan so I can find it.
Oh, wait, that should be at the very beginning. There you go. So you can just get it from here.
Okay, thank you.
No problem. Yes. From
Not the ones that
the
we
essay
just
session?
did? Yeah.
Yeah.
Well, no, not from the essay session. From like the first hour, like the 40 something questions.
You mean the last few ones? This one?
Is this one with the 40 questions on it? Yeah. So just like the whole document.
Yeah.
It's on Canvas.
I'm gonna, yeah, the blank version is on here. Yes. You can walk. I just prefer that. We prefer that. You don't think that. Yeah. Okay, that's a mistake on my part. That's my previous schedule. Yeah, the one on the front. Because this is a normal ether with a base. These ones are not going to be reacted. Normal ethers are only going to be reacted with acid. Because the rule was that if you cleave, you flip the bond. Because technically it's going to be like an sp2 attack, so that's why we flip it. Usually your professor is not going to give you the question to stereochemistry, so as long as you know where to cleave, you should be good. No problem. Yes, I'll go. Yeah, that's the word. Yeah. When can it use the